Welcome today. Welcome to the second live stream of me learning SurrealDB, where you can follow my journey of learning SurrealDB. As a little disclaimer that I'm by no means expert on a subject. Stream will be a little bit shorter today as I'm a little bit under the weather and don't want to stretch it. So, today's topic is basically relations, because during the last stream we learned, the basics of relational things similar to normal SQL. Okay, we learned how to define things like fields, what else? Tables, databases, etc., and how to do basic queries. But that's just one side of SurrealDB. The other side, which we already scratched a little bit, was the fact that it's also a document database, so that we can have, data that doesn't have a specific schema. But the third side of it is the graph database. So we can specify relations between things. So let's explore that. I believe we can do some things here. In SurrealQL section, I believe there was something about relation. There we go, relate. So let's read up on that and see what we can learn. Relate statement. The relate statement can be used to generate graph edges between two records in a database. Okay, so graph edges. By graph edges, one might understand that we have some kind of field, right? Let's actually make it no strange colors, all right? So let's call this will be record 1, right? And we have record 2, and maybe we have record 3, okay? So the relations would be where we specify something like, hey, there's a relation from record 1 to record 2, okay? And we can actually make it, maybe this will be person Anna, okay? This will be person Anna. This would be person John. And here would be, let's say, not person, but something else. Comment ABC123, okay? Just some kind of comment. So with relations, we could specify that John follows Anna, okay? Maybe it's some kind of social media app and he follows Anna. So this is a relation from the same table to the same table. And usually what's possible is that we can attach additional data to the relation, like, since, and we have some date. I don't know. Let's say that also if he followed the person, we can say, what would be a good word here? Medium will be app, for example, right? The mobile app. And we can attach it here. And we can also make a relation where, for example, he also, the platform allows to leave likes, so likes, okay? But we can also make another relationship that, let's say, Anna wrote comment, okay? And also John can like a comment, right? So the whole idea is that we can have the same name for relationships and whatnot. We can basically start making this points at that point at something else. Maybe we have yet some other person. Person. What else? Fred, right? And we have a relationship where Anna actually likes Fred, okay? It's in that direction. So we could basically try to make a query that, hey, return me all the people that John, or something more like, take John, get all comments that he liked, and return all the people that authors of those comments liked. Something like that. So you can go a little bit crazy with those. I mean, this is not the perfect example, but the whole idea is that you can then traverse the graph of how things are connected and search through them rather than constrict yourself to specific tables. Because just like with likes, it could be from person to comment, could be from person to person, or maybe in a different direction. Maybe it's a AI app and comments are sentient and comment can like people, right? Who knows what the future brings? Could happen at some point in our lives. Actually sounds like a cool idea for some experiment. But, something of this sort. And suddenly it resembles a graph rather than a bunch of tables. So getting back to our relate statement. So we can generate graph edges with this relate statement. And by graph edges, we mean literally those arrows, right? Because these are the edges of the graph. While these would be considered nodes at that point, in that terminology. This allows us to traverse related records efficiently without needing to pull data from multiple tables and merging that data together using SQL joins. That's exactly it. We can just traverse it rather than doing complicated stuff. So edges created using relate statement are nearly identical to tables created using other statements. The key differences are that edge tables are deleted once there are no existing relationships left. Okay, so here's the new term, edge tables. So I did some perusing of the documentation before, and I recall seeing that here and there, probably partially here. So the whole idea is that when we define, something like wrote, okay, what happens is that basically behind the scenes there will be a new table, like edge table. Let's call it edge table for wrote, for that kind of relationship. And what happens here is that we have three, what would you call it, columns to it. I mean, yeah, we have the ID of the relation, right? That's rather obvious. Each basically relation, each arrow has its own ID. But then we have in, which is basically from where it's coming, the direction is going, so from. And then we have out. Okay, that's what happened here. And then additionally, we have all the extras that we could assign, like here follows has sense and medium. It can be specified, it doesn't have to. And that's basically, the ID in and out is what's being created in a background for us. So the edge tables are deleted once there are no existing relationships left. Okay, so if we remove all the likes relationships, the table will be removed. And I presume this is only for the ones that are automatically generated, because with the define statement, I believe we can define our own edge tables. So I guess those won't be removed because we define them explicitly. And edge tables have two required fields, in and out, which specify the direction of the relationships. These cannot be modified in schema declarations except to specify that they must be of a certain record type. Okay, so like we mentioned, we have in and out, and they usually accept anything. The relationship, by default, the relationship can point from whatever record to whatever record. Doesn't matter what table, as long as they are within the same database, I presume. I mean, it wouldn't make sense to be in a different way, but within the same database to between any tables. But we could specify, oh, there we go, wrote. We can specify that we can define a field in, even though it already exists on this table, but specify that the type points to record author. So, well, out is book. So this is basically arrows within that road can point only from author to a book. That means it can point to book to author or from author to article or something. Just between those two. But this will be ignored if we try to specify that it's a string or integer. So I guess it won't throw an error. It will just ignore it. Sure. Okay, no big deal. Otherwise, edge tables behave like normal tables in terms of updating, defining a schema, or indexes. Okay? So that's it. We just have two required fields that are extra, and that's it. Makes sense. That suddenly sounds like we can query them in a different way. So record lengths are the alternative option when connecting data, and simply consist of a field with record IDs that serve as unidirectional links. The key difference is that graph relations, so record lengths is what we were doing previously, where you just define a field of type record author, which points at some kind of record. And we already established that, I believe we established it, that the record doesn't need to exist yet. You know, it's just we're defining it here. It doesn't have to exist. So the key differences in graph relations are that they are kept in a separate table as opposed to a field inside a record. Yep. And they offer bidirectional querying. Yeah, that means that, you know, when we define a field on a type, let's say author, we can only query it from within that author. We can go from author to a book. We can't go the other direction. We would need to first find the author that has this specific book assigned to it. So, you know, a workaround. So they offer bidirectional querying. So I guess we will be able to in this specific case, it will be possible to, when we have a specific book, to check who wrote it, or the other way around. Okay. They offer referential integrity. That's interesting. Doesn't mean that they can. I wonder what happens if we have an author pointing at the book, and then we remove that book. Will that relation exist or will it disappear? That's interesting. And allow you to store data alongside the relationship. Yes. And we have the statement syntax. So we'll try it out in a second. Save relate. We can specify only from record, arrow, table, arrow to record. Okay, so we'll probably have author 1 to 3, wrote, book 3 to 1. Okay. And we can specify additional content or set or something. Okay. And then return none. Okay, we can control what is being returned. Timeout and parallel. Okay. Before using the relate statement, create the records you want to relate to. You can do this using the create statement. If the records don't exist, an empty array will be returned. Oh, so look at that. We can't specify relation unless we have the fields. So again, what happens if we have a relation and we remove one of the records? I really need to test it out. So let's fire up the Surrealist. And we're gonna get our sandbox. I'm gonna reset it and let's play around. So let's say that we will do define table. We'll install a new version a little bit later. But let me just take a peek how we were defining table. Okay. Schema full or not schema full, so we'll just make a table author. Schemaless. Okay. Then we're gonna... Yeah, sure. We've got that. And define table book as well. We don't care what stuff is in there. Okay. We've got those two tables. So on the designer, we see that we have both author and a book. So yeah, let's create a first author. Create author Terry Pratchett. Okay. And we're gonna set that the name is Terry Pratchett. Okay. Sure. That should be enough. I guess set requires equals. Yes. So bam. We've got our first thing. We have the ID. We'll remember it. And we're gonna also create a book. Color of magic, right? I think that was the name of it. And we run a query. There we go. So we should have two books. We have one author and one book. So now let's figure out how to do the relationship. I recall it was relate. Relate something. What's the relationship to something? So let's take a peek. Relate author Terry Pratchett. An arrow will be wrote. Another arrow will be book color of magic. That's it. Well, let's also do set. Like we want to add a field. And let's see, when was that book written? Well, we have a little thingy when it was released. 1983. Wow. Year equals... we can make a number, right? There we go. Because if we would put quotes around it, it will be a string. So, sure. All right, we got ID, wrote, and some random ID. Author, so we have in, out, and a year. So in the designer, we suddenly have also wrote. Interesting. Table type Annie. Huh. So, sure. In an Explorer, we can see that there's wrote. And so from author to book and the year. Okay, that makes sense. So what if we would try to make also a relation from author to that wrote book doesn't exist, like whatever, right? It shows as if it did it. That's interesting. That was supposed to fail. Explorer. We have those two. The book, whatever, doesn't exist. Well, so much for that. I guess the documentation is lying to us. Because we don't have the book, but the relationship exists. Okay. What happens if we're gonna delete the color of magic? Will the relationship stay? I believe I can just go here and do, you know what? Let's do it through a query. Delete book color of magic. I don't know if that was through delete or something else. Look at that. There's no. Wait a moment. Oh yeah. The book disappeared. Okay. And the relationship that was pointing to it disappeared as well. Okay, so we can count on those relationships to be disappearing when necessary, which is cool. But, well, it allows us to create it allows us to create a relationship pointing to something that doesn't exist. What if I'm gonna try to create something the other way around? Let's say I want something where I point something that doesn't exist, like author me, to book that doesn't exist. Still worked. Okay. So, and here in the documentation, So they offer referential integrity. Not really. So before using the relate statement, create the records you want to relate to. You can do this using the create statement. If the records don't exist, an empty array will be returned. False. So maybe that worked and stopped working. There was just maybe no test in the database to catch that. Interesting. So the following query shows the basic structure of the relate statement, which creates a relationship between a record and the person table and the record in the article table. For table names, we prioritize readability, such that normal tables are singular person instead of persons, but edge tables can be plural. Okay. So relate person, wrote, article. Okay. And it created this. So that's cool. There is no relationship information stored in either the person or the article table. Yeah, that's the important part. In our case also, neither the author nor the book actually have any information about the relation existing, which is kind of nice because it's often that, you want some kind of either one-off temporary little relationship between things that maybe isn't being used like a lot or something, and you just want to relate things quickly. You don't have to modify the actual records to have that relation, which keeps things separate. Instead, an edge table, in this case a table called wrote, stores the relationship information. The structure in arrow ID arrow out mirrors the record IDs from the relate statement, with the addition of the automatically generated ID for the whole edge table. For the wrote edge table. Okay, sure. By default, the edge table gets created as a schema-less table when you execute the relate statement. You can, however, make the table schemaful by either defining a schema before or after executing the relate statement. Yeah. So, we could define... A common use case is to make sure only unique relationships get created. You can do that by defining an index. Define index and the name. On table, wrote, so that's the edge table. Columns, in, out, unique. So that will make that we can only define one wrote relationship from and to. Okay, I see. So in our case here, we could basically, in our design, we see that wrote has... there are no fields defined, but if we look at the Explorer, we can see that in this case, it's author, and out is a book, but nothing stops us from making relate author to author, which will be me. Okay? That's a silly relationship, but it's possible, right? An author wrote itself. Sure. Can you do that in SQL database? I wonder. I never tried to make like a self-referencing relation in SQL database, because then when you try to delete it, well, it's gonna prevent you forever. Yeah, so when we go to Explorer, we should have more relationships, right? From author to author. So let's just get rid of those. Delete record. Wait, oh, it doesn't exist. I mean, the whole relation. Delete, okay? So what if we're gonna make it where, we'll leave that here for now. We're gonna do define table, because we can define a table, wrote, and no, let's ignore that. Let's do define field in. Wait, was it define field table? On table. On table wrote, and the n needs to be always an author. Type, it's record of type author, okay? And we're gonna also do basically the same thing, but for the out field, we always wanted to point to a book. But before we do that, is it possible to point to a table that doesn't exist? Article, whatever. Article A. Can I run this? Yeah, it allows me. And it didn't create a table. It just says that, hey, this record doesn't exist. Okay, cool. So it's very flexible. It allows me to make relations between things that don't exist yet. Interesting. So let's define those two, in and out, with specific types. I run this, and I try to run this. Bam, error. For out needs to be of type record book. Exactly. So that's the thing. It needs to be a book. Run, and now it worked. Okay. So let's add that index that can be, because right now, what do we have here? We have, oh, look at that. This now shows edges. It didn't do that before. Interesting. Hello, Mithridates. Welcome back to live stream. Mithridates says, yep, you can relate first, and once you create the record, they point to the something wrote article type of query. We'll show you. Yeah. Okay. So yeah, I was just confused by the part that in the documentation it suggests that before using the relate statement, create the records you want to relate to. If the records don't exist, an empty array will be returned, which in my case isn't true. We get an array with the actual statement. So, well, discrepancy. I guess I'll add an issue after the stream. Mithridates says, yeah, that was a funny warning. I just noticed that it's not in the 2.x docs. We'll make a change there. Ah, okay, because we're in 1.x, but there's 2.x coming, which I don't know what the status it's in. I know that when I tried to deploy it, it didn't work through Docker, so I didn't bother switching to it during this live stream. I'll do it after the official release. happens. Okay. So I just wanted to check, if we can actually define the same relationship twice. Where were we? Here. So we have our third project, road book, whatever. Let's just remove that one, okay? Let's re-add our book. And doesn't this have like query history? Where we created a book. There we go. Open a new tab. There we go. So let's run this query. We've got our book again. We run it again and it should be error. Yeah, it already exists. Cool. So let's relate the author Terry Pratchett to the book Color of Magic. Okay. I can get rid of those two here. Run. So we created it, and here we can see when we refresh. Oh, it's already here. There's a relationship. There's no year set, no biggie. What happens if I click again? We got a different ID. That means when we refresh that we have that relationship twice. Yep. So as far as I remember, quickly from memory, I believe we should be able to do select wrote book Color of Magic from author. Okay. In this case, I'm saying author. Yeah, I mean, take the author, or like more like get me the author that wrote the book Color of Magic, I believe. There's a problem with the database. Please fail to parse query line. Huh. What am I doing wrong? Does it need spaces? That would be strange. Nope. I guess we'll get to querying in a second. Because we have insert into basic of querying graphs. Select in from road. Select. Oh, no, it's good. Dash something, road, and from person. Yeah, we're trying to do something like this. Unless it's not happy that we're trying to get a specific thing. Oh, I see. Author Terry Pratchett. Okay, we're getting empty arrays. We'll get to that in a second. So let's just read through it properly. So we just wanted to find out index so that we can create duplicates relationships, right? So define index, the name, on table, road, columns, in and out. So we can actually copy it and just say, hey, let's define index. Let's call it unique road relationship. I don't know what's a good naming theme for those. So we'll be on table, road, columns, and out will be unique. Something tells me this should fail because we already have something that breaks it, right? Run. Bam, already contains this with record that. Ha, so we can't. So we would actually need to go manually, say that, you know what? Let's delete this one because this one is a copy. And run it. Found article A for field out will record blah blah, but expected record this. Oh, that's interesting. So that means that this will also check for inconsistencies with this, because this is author pointing to an article which shouldn't exist. Cool. So this guy, relations, content, delete this guy. Okay. And now it's fine. So in theory, we should have the index. Go to the designer. Oh, look at that. Author connected through road to book. And we have index. Yes, unique road relationship. Perfect. All right. So yeah, this is cool. So that means we shouldn't be able to define another relationship like not selects, but yeah, we shouldn't be able to create this relationship again. Yeah, because it already exists. Cool. So at least that works. The edge tables are bidirectional by default. To enforce unidirectional relationships, you can restrict the type definition using field definition. So yeah, that's what we did, because we could have things. Before that, things could be any kind of way. But I wonder if we could make it bidirectional, but just for those specific types, because what if a book could like the author? I know it's stupid, but what if? We had this one query there that we used at some point to specify the fields. There we go. We had this query. We defined in to be pointing to author and out pointing to a book. Can I do like or book, author, or book? Is that possible? I think it is. Look at that. What the heck? Okay, this is, I guess this points to a book. Yeah, they point to each other now, and it just really struggles to display it. So field N, that can be author or book. Okay, so that works. So that means that we should be able to define a relationship where, this is for road, so we can have a relationship where the book, Color of Magic, wrote the author, right? And that works. It's allowed. We just can't create it again. But the problem is now that, sure, we have it bidirectional, right? If we go to road, we can see that it's Terry Pratchett wrote Color of Magic and Color of Magic wrote Terry Pratchett. That's fine. But I think that our definition allows us, for example, author to write an author or book to write a book. So I could make that the book wrote the book itself, right? Yeah. And suddenly we can do that. That's not great. I wonder if we can use an assert on relations. Because when you define a field, there is a concept of an assert. Asserting rules on fields. You can take your field definitions even further by using asserts. Assert can be used to ensure that your data remains consistent. For example, you can use assert to ensure that a field is always a valid email address or that a number is always positive. So, that might be actually more difficult than I think. So, when we define a field, you can also add assert. For example, string is email and the value. So the whole value thing is the thing that we try to assign to the field. And I believe that we have a few other additional things like before and after to see what was the previous value, what is the new value that we want to set. But is it possible to get the whole record? I recall there was something about that. Parameters. Before and after. Represents the value before and after mutation on field. Okay. Authorization, event, input represents the initial inputted value for the field in the field definition. As the value, okay, so that's not it. Parent and this. This represents the current context in an operation. When inside a subquery, parent can be used to access the parent contexts. That's not it either. Scope represents the name of the scope of currently authenticated user, null, session, token, and value. Represents the value after a mutation on the field. Identical to after in the case of an event. Yeah. I wonder if something like parent is available. No, because this is probably in context of operation. Yeah, I really wonder if asserts could actually do something with the thing itself. Because we could... where's this? Let's say that for the field in, we could add assert where the input dot year is larger than, I don't know, 1900, right? Because we don't want old books in there or something. But this will apply depending on if it's an author or a book. Mithridate says, yeah, you can use parent in a schema definition. Like parent inside defined field refers to the table. Oh, that would be so good. So, so let's try to do it. So assert that the parent.out and I think we can just take a peek at data model. Because our record IDs, we should be able to identify what table the record is pointing at, right? And SurrealDB document record ID stored both the table name and the record identifier. So we have types of IDs, right? Numeric, object-based, and all that stuff. Maybe there's something in functions. Database functions. How could we get the table that the ID points to? Duration, encoding, geo, HTTP. Yeah, because our database can actually make HTTP requests, which is nuts. Math meta functions. Extracts and returns the table ID. Extracts the return table name. There we go. So meta table of a record. There we go. So we should do meta table of what the out is pointing to. It should be different than meta table of input. So what that means is that whatever we try to write into in should be different. I mean, the table should be different than this one. This should prevent author pointing to an author or book to a book. It should be only author to book or book to an author. So we can define it here or we can define it in both. And I mean, it doesn't matter, I guess. But what happens if I'm gonna do it? I'm really curious. We would like break the database. It accepted it. Okay. So in our Explorer, We don't have book pointing to a book right now, I think. We have, okay? So let's get rid of that one, okay? What just happened? A bunch of them disappeared. What? Oh, I deleted a book. That's why. And the author. How did that happen? What the hell did I do? I have no idea what I just did. Okay, let's quickly recreate them. I believe I have it here. Create a book, Color of Magic. Okay. And we're gonna create author Terry Pratchett. Okay. All right, we have them back. We don't have any other relationships. So now we can define that the author, Terry Pratchett, wrote the book Color of Magic, right? Run it. Incorrect arguments for function meta TB. Argument 1 was the wrong type. Expect a record but found none. I think I know what's going on. So when we define this, I think the parent here relates to basically it is the record or whatever, the table. Is the table or the record? I would expect that this is a record, but initially is absolutely empty because there's nothing there yet. Because the assert is being checked before anything got created to see if it is to be created. So I guess both asserts will just fail. And if we make them like, oh, if it's to allow null, the second assert will run also where the parent is the record that doesn't exist. So I guess we can't check that. We can't reinforce that these are not pointing to each other. That would work if we would create two different road relationships. Interesting. Very interesting. I guess we found a limitation. So I will redefine them so that they don't have that. Okay. And this way we'll be able to just create the thing. Okay, we found a limitation. I'm fine with that. Let's continue with our relate, because there's more to learn here. Yeah. Always two there are, no more nor less. A relate statement that involves an array instead of a single ID will not fail. Instead, it will create a graph edge for record in the array. For each record in the array. So if we'll say insert into cat ID, oh, this is like SQL thingy. So we basically create a bunch of cats with IDs, Mr. Meow, Mrs. Meow, and Kitten. And if we relate an array of IDs to some ID, it should create both of them, like from cat meow to kitten and from Mr. Meow to kitten, and from Mrs. Meow to kitten. Okay. Similarly, a relate statement that involves two arrays will return a number of graph edges equal to their product, in this case 2 by 2. So we can basically say that both Mr. Meow and Mrs. Meow are parents of kitten and kitten 2. Okay. Oh, I want to try that. So in our database, we could create new author, right? Let's do create. We're gonna create two new authors. Okay. I just need to look up the name. Ba, 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 ba. So we'll have Daniel Abraham. And we're gonna have Ty Frank Ty. Huh, interesting. Okay, so we can create those two authors. Okay, they're created. And we also could create a bunch of books. All right, so let's do that. And a book. Let's search for Expanse books in order. Sure. Maybe they will be listed out in a nice way. There we go. We're just gonna copy it and clean it up in here quickly. Oh, oof. Can I just do this? Yes, I can. Sure. So let's just copy this. We'll just name them B1 so that we can just do it quickly. B2, B3, B4, B5, B6, and 8, 9. 7, 8, 9. Because there's 9 books as far as I remember. So yeah, we've got this one. And let's just make them all double quotes so that we don't have problems. There we go. Bam. Bam. By the way, amazing books. The Expanse series is mind-blowingly good. Okay. And the last one. There we go. So we can just run this to create online books. Okay, there we go. We'll go to our Explorer. We can see the author. We added two, Daniel Abraham and T.Y. Frank. And we could actually go with an extra thing because those two authors use the pseudonym James S.A. Corey. Okay? So that means that we could actually create one more author. Okay? James Corey. Okay. Let's create him. And what we should be able to do now is actually do something like relate. And we take the table of this author and this author and that author. Make an arrow, wrote, another arrow. And we just copy those books. 2, 3, 4, 5, B6, B7, and B8, and the last one, B9. Okay? We should be, and let's do set series is the Expanse. Hello, CPN. How are you doing? Glad you're here. So that means that we can relate all those authors to all those books. If we're going to run this, we should get 1, 2, 3 times 9 relations. There we go. It just keeps going. Or not. James Corey for those. And 2i Frank and all the other stuff. Yep, that worked. Go to Explorer, to Road. Look how many we have created. That is a lot of relations. Okay, so that's 100% great. Doesn't mean that if we would want to say that Terry Pratchett wrote all those books as well, can we do something like relate author Terry Pratchett wrote, and here we just grab a list of those books or something. Now those books don't have the thingy on it. Oh no. I don't know how that works. From author. No, what the hell am I trying to do? I would need to select wrote. Oh, we're gonna do out from wrote. Okay, so we select the property out, which is pointing to, from wrote, where series is equal to the expanse. I think this should return a list of IDs, right? I think. We just need to point. But something tells me this will return. This is we'll see. And set. Reason is joke because he didn't write that. I'm just put it in a new query so that we have something separate to deal with. And we're just going to put that set on a separate line so it's easy to read. Cannot execute relate statement using value bam. So there we go. Okay. Oh, because we return out. Oh, okay, I see. Mithridate says select value out might work. Exactly. So we'll do select value. So what value does is that, because right now, what happens here is that this query selects all those books and returns them as little objects that have the property out, because we could say as the book, right? So it'll be the book and then we have the ID. So the value, what it does is instead of returning it as an object of something with value, we'll return it just as that value. So we're skipping this whole wrapping in an object. And that works only if we're returning a single column, let's call it. Let's run it. Database index unique wrote relationship already contains author Terry Pratchett book B7 with record wrote. What? That's interesting. Hello, Gabriel. Gabriel says, hi there. Does SurrealDB support graph algorithms like PageRank? I have no idea. Possibly. Possibly. Mithridates might know a little bit. He seems to be knowledgeable with SurrealDB. And CPN says, I'm doing great. What are your thoughts on SurrealDB so far? So far, I really like it. I'm kind of confused with relationships a little bit from time to time, especially in how to query those things. But I think as I learn how to actually deal with it a little bit, where just like with everything, initially you find few roadblocks, which when you learn the specificities of how to work with, for example, this specific database, this would open a lot of doors on flexibility of how to deal with the data. And let's see if I can quickly get like a response for this thing. Let me copy it. Oh, does SurrealDB support graph algorithms like PageRank? Let's see if we're gonna get an answer. Because I am not familiar with graph algorithms, but it would be nice to know, as for the future. And CPN says, yeah, relationships can be hard. Yep. And that's why I'm hoping that SurrealDB might actually make them easier. Based on my review of documentation, there does not appear to be built-in support for graph algorithms like PageRank. SurrealDB does have good support for graph, the modeling and querying, but it does not seem to include pre-implemented graph analysis algorithm like PageRank, shortest path, community detection, etc. Okay, so no built-in support. Of course, the database is still evolving. Okay, so sorry, Gabriel, doesn't seem to that there is something of that sort. So getting back here, it says it already contains author their project to book B7. So what just happened? The Explorer, when we refresh the road, with their project, Color of Magic. And another page. That's it. So this doesn't seem like it should be the case. Yeah, the entire project points only once to the Color of Magic. So this shouldn't be possible. Already contains author to project book B7 with record CC8L. Does this one is CCL? No. So something tells me that when it tries to relate those books, we might have. Oh, I see. That makes so much sense. So it found. So what this query was doing is that it takes the road table and it gets all the records from there. Then it finds all the records that have the expanse to it. And then it outputs the IDs. So then we try to create those, and index is being updated and whatnot, all in one transaction. And while this happens, turns out we tried to create one relationship twice. And why is that? It's because wrote, for example, to book B7, here we have from James Corey to B7. And then we have from Daniel Abrams B7. So we have so many relations. We have 3 relationships per book already. So this is bad. So we would need to make them distinct. How do we do that? I think there's something like array distinct or something of that sort. Is it possible to do it? I do not know. For now, it fails to parse the query. Run. There we go. So what array distincts does, we can actually read about it, I believe. Functions, array functions, there's like tons of stuff. Add, all, at, boolean, bunch of stuff, grouping and whatnot. But there's distinct. Returns the unique items in an array. Okay? So we can give an array of, so let's say 1, 2, 1, 3, 3, 4, and removes duplicates. And it also works for things like IDs. So this way, we took our query that returns the IDs of books from the series The Expanse, but they are duplicated each 3 times. So we basically remove duplicates. But do we need this extra parentheses stuff here? We don't have to have that. Okay, cool. It's just the syntax highlighting gets confused. So basically we took the subquery, put into remove duplicates, and that's it. Yeah, we've got this. We just need to wrap in parentheses so that it knows the subquery. And we created those relationships. So now Terry Pratchett should be showing up in here a lot. There we go. Or not. Refresh. Terry Pratchett to book B7. Terry Pratchett to book B2. There we go. So this was our first query. No, we didn't query relationships per se yet. Okay. But interesting. I like tinkering like that. That's fun. So we learned that we can basically relate a bunch of stuff to a bunch of stuff. And inside there, we can just, when creating those relationships, we can also query things, which is super useful because that's how we can create a lot of relationships. I can already see a way to replace the, what was it called, record links with relationships, or with, with graph or edges or whatever they call it. It's very confusing. So adding data using set and content. Graph edges are standalone tables that can hold other fields besides the default in, out, and ID. These can be added during a relate statement or during an update in the same manner as any other SurrealDB table. Let's look at the 2 ways you can add record data to the relate statement. Both of these queries will produce the same result. So one is with set. So we relate from person to article. And we set time.written is time now. So this will create an object time that will have a property written inside the row. So it will have a column time with property written. Or I noticed that you can also specify the content, which is a bit more like JSON. It's just you don't put quotes here, although you could optionally. So yeah, this is basically the same thing. Here is an example of graph edge being updated in the same way as any other SurrealDB record. So we can basically do update. Oh, so not relate, but update, wrote. So on all the wrote entries, we put description. Oh, look at that. Description is the table name of what we're pointing to. We add written by, bam. Sure. And this will basically update. So everything. I like that. Let's run this. This should just run in our table, no problem. So we do update wrote, where we said the description is table out, written by, table in. Sure. Run query. And we have book written by author, Daniel Abra. Book written by this. Book written. Okay, so this is just a table. Okay. String in. Interesting. So we're converting whatever was as the record ID into a string this way. Interesting. And that updated all of our properties. It doesn't return how many were modified. But if we go to Explorer, Wrote, and Refresh, we can see that every single one has a description. Cool. Creating a single relation with the only keyword. Using the only keyword, just an object for the relation in the question will be returned. This instead of an array with a single object. Yeah, because when we do without only, like, yeah, let's make an example. So if we create an author, let's create yet another author. Author, I don't know, J.R.R. Tolkien. Okay. When I run like this, we get an array, which in this case is an array of queries, where we get the object itself that we created. So if we're gonna do create only an author, like, well, we don't return this list anymore. I mean, that wasn't a list of queries, the previous one. That was just a list of objects returned from the query. But here we just return just the object, no list anymore. And if we would try to return two things when we have only specified, it would just error out, like, sorry, this needs to be limited to just one element. So you'll see only, like, when you're querying with select, and you see only, you can be sure that at the end of the select query, there will be limit one, to just limit to one entry or something. So that's useful when especially when being used as subqueries. Okay, so basics of querying graphs. Now we're getting to the stuff that's confusing for me. But at least we have some data, right, that we can query. Let's look at how the above gets queried. For more examples, see the select documentation. We're gonna get there. For the questions below, each of the queries will give you the same answer. Oh, note that whether this arrow and that arrow are parsed as in or out depends on the direction of relation that the graph edge wrote. An arrow pointing toward wrote corresponds to in, and vice versa. Sure, that should be simple. So basically, who wrote this article? And all those queries say that. So who wrote the article? So we'll do select in from wrote. So we take the table wrote, and we basically, for each record, we return in, which is, because our relationship is from author to the book, that means that in is who wrote the book, the beginning of the arrow. So because this is just a column and a table, so that should work. But alternatively, we could do select wrote.in from person. So we take person, as far as I remember reading it somewhere. Reading this backwards then makes more sense. Yeah, so I like to do it backwards. So take the person, or like a input of the relationship wrote from the person. So person gets placed here, that wrote, and we take the in, which is the actual person. What the heck? That's so weird. Can I actually run those and see if the results are similar? Although in our case, it'll be author. So select in from wrote, right? And we've got all those all the authors, and they are duplicated a bunch of times. So what if we're gonna do author? Let's take author, and from author, we want all the relationship of wrote, from which we want the in, which will point back at the author. So this won't return just all the authors. It will only return authors who actually wrote something. Okay. So if I'm gonna quickly, we already have the author Tolkien and Herbert. They shouldn't show up anywhere because we didn't add any books that they wrote and we didn't specify the relationship. So if we're gonna run it, we have nothing. Oh, we were missing H. There we go. So, okay. Yes, thank you, Mr. Rates. I know the YouTube chat comes in a little bit late usually. So our query returned bunch of things. So let me explain my interpretation here. So this road here is because we can say as whatever, the author, okay? And this road will be replaced with that. There we go, the author. So look at that. We have a list of this thing where the author is a list of authors. Then we have this and that and a bunch of this stuff. So why is that? So let's think about it. We're taking each author, okay? We're taking, let's say first author will be Daniel Abram, okay? Then we're taking all the books that he wrote, which will be 9 books. Okay, all his wrote, the specific authors wrote relations, which will be 9 because he wrote 9 books. 1 to 3, 1 to 3, 1 to 3. This is 9 entries. And then for each of those books, or whatever wrote relations, we take the author of that relation. That means it returns itself 9 times. So, okay, I'm starting to understand that. That makes actual sense. Okay. Sure, so if we would do this, because this is n, and another wrote.n, we're gonna have a lot more because we just duplicated them. Oh, this is silly. Hey, if you want to, you can do it. Sure. All right. What were the other queries? One like this. So let's take a peek at that one. So from author, we take the author. For each record, for each author, we go, hey, who wrote it? And who, the right relationship. And I guess then take that relationship that was sent to that person, we can take back this way instead of in. So it will be author. We should have exactly the same thing. Wrote, and then we have additionally author. Huh. Okay, that's surprising to me. Can I do wrote as relationship? I can rename them. And then this will be as the author. Nope. So we were able to rename this one, but we weren't able to rename. Can I, like, in parentheses or something? That doesn't make sense. Whoa, 100% not make sense. Huh. Okay. So I am able to rename this, but I am not able to rename that one. Interesting. But very strange that, so we basically take the author, get all of the authors wrote relationships. So they will be listed here, but it's not a list, it's just an object. And inside that we have an, what the? Okay, I must say this is very strange. But that also suggests that I could do where something dot something dot something. Hmm. Huh. I totally didn't expect that. What about this? We have the other arrow. Article. Oh, we can query it from the other end. So we can do book. So I can take books, each book, and check who wrote it. I mean, get all the relationships that point to the book that was written. And the author, or probably the person. Yeah, there we go. I mean, not person, author. Huh. This is such a strange way to query, but I'm starting to get it personally. It's just totally not understanding why is it nested like that. Which article did the person write? So select out from wrote. Okay, makes sense. So person, so this is basically the same thing, copy pasted, just for the out. When was the article written? Okay, so this was for the situation where we had this whole thing where we had person, wrote, article, and on the wrote relationship, we had the time.written set. So in here, we can just select from wrote, so all the relationships, and just get time written as time written. Okay, that's that. So again, this is very simple. Or from person, select all the relationships that that person wrote. So basically for each person, where time.written is set as time written. Okay. Sure. And the same thing could be from the other side because we just switch the arrow. So let's look at this. For a more complicated query, like the one below, you can use a simple rule of thumb. Place the subject in front of the graph selection and then read it backward. Okay, so we have this long query. So from. So we take person Toby and we just plop it here. So it's actually, oh, we actually have it here. So we put it in front. So we have person Toby, purchased product that was purchased by person that purchased. Okay, so to the right, we can, if the arrow is pointing to the right, we can read it that. Like, you know, Toby that purchased the that purchased a product. And the other arrow is the, I don't know, different form. I don't know how to call them in language. That was purchased by a person. And that person that purchased product. So reading backward. Select, there we go. Select every product that was purchased by a person who purchased a product that was also purchased by Toby. Yikes. This is fun. Sure. I really wonder what the kind of return thing it would be. Yeah, alternatively, you can break it down in steps. So, starting with Toby and his purchased product that were also purchased by a person, what are all of those persons' purchased products? Putting it all together would be based on all the products Toby purchased, which person also purchased those products and what did they purchase? So using let parameters in relate statements. You can also use parameters to specify the record IDs. So these two statements store the result of the subquery in a parameter. The subquery returns an array of IDs. So we define a parameter person where we do select from the array person, select all the IDs. And then from the array article, select all the IDs. So we get all the persons and all the articles. And this statement creates a relationship record for every combination of record IDs. So basically relate from this array of persons, wrote, and from array of articles. Okay, so sure, that's just a hint, like, hey, you could do it that way to get the arrays. Okay, so our statement where we tried to make a subquery could be just simplified to this to make it more readable. Makes sense. Using the return clause, by default, the relate statement returns the record value once the changes have been made. To change the return value of each record, specify a return clause specifying either none, before, after, diff, or comma separate a list of specific fields to return. Oh, so we could just say, hey, don't return any result because we don't want that spam, or return a change set diff. That's interesting. Record before changes were applied. Okay, so before, after, okay. And return specific field, which will be time. Okay. I can see it very useful when, let's say, your backend makes some changes to the database. And instead of having all the fields return whatever, you might want, you know what, just give me, I don't know, the new time or the ID or something else that I will need to use in my next step in my backend. Or this could be also probably used in subqueries, Oh, that would be really nice in subqueries because you can do a bunch of stuff and just get a list of maybe those IDs or something, and that's it, and use it in the next query. And timeouts, so just say that, you know, if this takes more than 5 seconds, just abort or something. Because we want to select everything from person where, oh, that's interesting. This is a new kind of query. So we want to get the person where the person knows. So take each person, check who they know, get all the people that they know, and also they know all their relationships. But they know, but the relationship needs to be set as influencer is true. Oh, and then timeout file. Okay. I really like that because this wasn't specified anywhere. This is how you can define the extra parameters. So in where statement, you can already specify some kind of something. So we're gonna get the persons returned anyway, I think. But we want to limit which persons we're selecting using this relation here. And this knows relationship has also additional thingy. Okay, this is the powerful stuff. I want to test that. So can we do it in our little database here? What if I want to, because we have some of them have reason joke, the other have series expanse, and we don't have anything else. Maybe we could add something where, let's try to make a query that takes all the relation, that finds all the relations that specify that the series expands, right? And adds that the tag, the book has additionally, just moves it to the book itself. So yeah, let's do a few exercises. So we want basically to update book. Oh dear. How the hell do we do that? we had an update example here, right? Update all those relationships with this. So in our case, we don't want to update the relationships. I think we need to update the books where the book was written, but we want to have the wrote. So the book was written where series is the expanse. Okay. And we want to set how about, because we would just set that the thing is series the expanse. Okay. That makes sense. So update set. So I guess we need to do this. Update book this. Where that. Okay, I think that's it. Try to run it. Nothing in response. That means nothing changed here, right? Books have nothing extra. Do I have like a wrong query or something? For book that was written, but do we start with that book? What was the thing here at the end? No, we just had this, so we should have just that. So that means take each book, look for who wrote it, and only that. Oh, there we go. So we have those 9 books. Okay, makes sense. Now it worked. And we shouldn't have duplicates because this checks it off the first time. Because the where statement, we got the first one working. Yep, that's the book. We add the thing in there. And if we go to Explorer, we refresh, we have it here. Cool. So now let's reverse that. So I'm gonna do update book set series is none. Okay, I'm just gonna update all the books and erase all the series. Bam. And setting it to none just removes the field completely. So given that, I want to do something else. I want to, instead of saying that, hey, set the series to the expanse, where, you know, there were books that the series was set to that, I want to find basically books that have the series set on them through the road. So basically all the relationships that have the series set in there, I want to attach that series to the book itself. So I don't want to have it hard-coded anywhere here. Whatever was set in the route ends up here. Okay, let's do that as level 2, because I already have an idea for level 3, because some books begin to multiple series. So just in case for now, I'm gonna edit the... How do I find it now? Here, Color of Magic, right? This particular relationship. I want to add that its series will be Disc World, okay? That'll be the series. So this means that instead of just those books here, we should have additionally set the series to Discworld to the specific Terpatches book. How do we do that? So again, we want to update book set series to, what do we set it to? This sounds like a subquery. So we could set it to select. We'll take the book. And we want the road relationship. We want to get the series. Okay. As series from book. I mean, that kind of sounds lame. And that should return a list basically, because we'll go through all the books. We should be taking it from the specific book that we're going through, but how the hell do we get it now? Okay, I don't know how to do that now. I mean, I can see how to do it multi-step, right? Because in multiple steps, we would do, I'm just gonna kind of separate it. I could do let and say that this will be relationships with series. Okay. And this is basically select series, and we can probably do just something like select value series from road, where road.series is not none, I presume. I don't even know how to check if something is none or not. So, but this should get us all the relationships that we have from that. And then, but how do we update those books? Okay, let's read up on update statement, because that might tell us a little bit more. Update. The update statement can be used to update or modify records in a database. This statement cannot be used to create graph relationships. So statement syntax. Update, and then this is targets, multiple. And then we either set content, or merge, or patch, or set, okay? And then we add a condition and what we're returning. So target refers to either record output, including an ID field, or record ID on its own. CPN says, this is really confusing. I'm sticking with SQLite. Yeah, this is confusing. But some of the things you can do is, it will be really difficult with SQL. That's all I'm saying. So update all records in the table. Just like that. Update or create a record with a specific number ID. That makes sense. Also this thing. And update only. And we just return the thing. When specifying fields to update using the set clause, it's possible to increment and decrement numeric values and or remove values from arrays. To increment a numeric value or to add an item to an array, use the plus equals operator. To decrement a numeric value or to remove a value from an array, use the minus equals operator. Okay, sure. So we can basically click count, increase it by 1, add Java to interests, or remove something. That's what we did once. Or unset email and address. Oh. That's interesting. So there's hidden unset. Was it set here somewhere specified? Oh, there is unset. Huh. Interesting. The update statement supports conditional matching of records using the where clause. If the expression in the where clause evaluates to true, then the respective record will be updated. So update all records which match the condition. Update city. Set population to this, where the name is London. Okay, so again, just that. So from what I understand, this is literally a list of things that need to be updated. As in city as a table is basically the whole table, so we'll iterate over each record. Or if we give it a list, it will iterate over some other list. Okay. And then we have just merge, patch, which we're not interested in right now. And there's the returns. And update statement will work on any value as long as it is a record ID, or if it contains an ID field, which is a record ID. Okay. So create person set and then set whatever, Toby. Select value from this and there, where name is Toby, and we update Toby. Okay, sure. And at the end, we have the timeout. Like update person, set important is true, where this relationship. So this is something similar to what we did. So basically update each person where that person knows another person that knows an influencer. Okay. So that's how we can specify those books, but it has we have no way of getting the value from the where clause into our set clause. So that's a separate query. And I don't think we can get this specific. I mean, if we would be able to get the person itself, oh, unless we use this. Hey, let's try that. Maybe we can do something like update author, set reference to self is this .id. Will that actually get all the authors and add a field reference to self and set it to the ID of the author? Is that true? Yes. Okay, so we can use this to get it. So this way we could basically say that, hey, update book, or yeah, sure, where we set the series to be, instead of from book, we get from specific thing. So the specific thing get who wrote it and series as series. Okay. All right, this is starting to take shape. Huh. So we basically get the book, check who wrote it, and the series. But we would basically need to say about where the we can set it here, I hope. Or not. Probably not. Ay. Okay, this is lots of, because I was thinking that maybe in select we can specify the limit here, but I don't think so. So we would be able to say where wrote, where series is not none, I think. Although we could probably do this, where wrote.series is not none. Okay. So this will limit the Yeah, this will limit those here so that we don't do those. Although this could be probably moved completely out of this subquery. This way we won't even process books in the first place unless they have that. Yeah, let's do that. Although now, I think it needs to be in both places. Oh my gosh, this is really confusing. I think this is the query. So we want to update all the books where those books were written, where the books had the road relationship pointing to it with a series attached to it, so that it's not none. Okay, and only those books set the series and basically select from that book, takes the road relationship and get a series out of it. And instead of as a series, I will do select a value. And this will return probably a list of values here. Because some of the books will have probably, are written by several authors. And each of those relations have specified the series on it. Therefore, those books will have tripled. So let's try it. Series. Oh, not really. It's just one. And then we have query 2. Oops. Ay. What did I do? Oh no. So I run this. And this again. So I need to run this thing again. Update book set series to none, where dot series is not, or is. Oh yeah, we just do this. We'll just clear the series, okay? So they're empty, and I just want to run this specific query, nothing else, because I run all of them. Cannot negate the value none. So we can't use this. How do I specify that something is not none? Another question. Because in SQL, I would just say is not null, and that's it. So, do we have in select? Have all those things. Using record ranges, skip certain fields from filter queries using the where clause. As with traditional SQL queries, the SurrealDB select queries support conditional filtering using the where clause. So where publish is true, where count is larger than 3. Oh, look at that. We have a nice example here. So from the profile, select everything, but that profile needs to so somebody's profile need to have an experience in organization, and number of those experiences need to be larger than 3 in organization. Interesting. That's cool. Conditional filtering based on graph edge properties. So basically select all the persons that reacted to posts, but those reactions were of type celebrate. Okay. Conditional filtering with Boolean logic, so where this and that, or that is equals to true. And select filter nested array values. So select address and only its elements. Oh, so from person, select their addresses, but only those that are active. Okay. Oh, this is really nice. So that's it when it comes to the to this. Interesting. We don't have anything else said here. Let's just take a quick peek at data model for none and null, because we can set those, but we have no way to compare them. So won't be in functions? No, it shouldn't be in functions. More like in operators. Checks whether both values are truthy. So this is something that reverses the truthiness of the Boolean value. Check whether either of the two values are truthy and not null. What? Return null, 0, false. Check whether either of two values are truthy and not null. What? I mean, return the truthy value? What? Okay, this is like a really bad example because it shows 3 of those in a row. I have no clue what that means. Either of two values are truthy. Okay, but are equal. So I want to check is not. So I tried to do this and it says I cannot invert it. So where is it? Is not. Is not. I mean, this should be an equivalent, right? I cannot negate the value none. Okay, it seems like this is being overcomplicated. All inside contains not in. There's no way to check if the value is null or if the value exists. Check whether the terms are found in a full text. No, this is all like AI stuff at the end. Yeah. So let me think about it because I know that one could do this. Where value is not none. Come on, because we want to check the series if it's null. And we need to return true or false. So I just do that. That sounds stupid. Okay, how do I return true here? Okay. Mithridates, if you're in there, your help will be much appreciated. But I don't expect you to be there again. I mean, still. How on earth do I check if the thing is not none? How do I do a check where I won't require the series to be there? Let's just take a peek at those. Check whether either of two values are truthy and not null. Louis Merlini says good night. Hello to you too. How are you doing today? If you know an SurrealDB, do you know how to check if the value is not none? Because I can't figure out a way to do it. Ay. Let me try that silly AI thing that I made. Maybe this is gonna have something. How can I check in the where clause if the Mithridate says where ... is not none should work, also putting an double exclamation in front. Okay, because is not none doesn't work. Well, I'll try to do that. It just says cannot negate the value none. So you're suggesting that I would do this? It's kind of ugly, but maybe it could work. Type is none might help. Oh, let me take a peek. Because if that's the case, it will be way more readable. So it is in functions. Type functions. Oh, look at that. Type all, type this. Type is none. Checks if given values of type none. So in theory, this could check if we have something, right? Huh. Type is none. Let's try this first. Kind of ugly, but maybe it's gonna work. What is the problem here? Fail to parse query at... Do we need to wrap this in this as well? Oh, we have double where, that's why. Run. Oh, now it worked. It just didn't. Well, we're gonna replace it with double quotes, double exclamation marks. And that worked. Okay. All right. Thank you, Gabriel, and thank you, Mithridates. And Louis Merlini says, II is Brasileiro man. I guess you're from Brazil, and you don't know this database. Okay. Hello to Brazil. Okay, this kind of worked. Okay, this double thing. So it takes, if there's a value, it will return true. But if not value, we just double negate it. So it will either be true or false at all times. So that makes me wonder, do we even need it? So here we have where we set the series to the expanse, then to none. Oops. And more of that. So basically, for all those, okay, I see. Let's look at that. So we took books, all the books that have the series set, right? Color of Magic had the series set as well. So that's good. So we found all the books that have the relationship where the at least one relationship. I think. Wait, what? So we take for each book, we check, we get a list of series. Oh, I see. So we get a list of series that... Oh, list of series that actually have... get a book and get all the relationships that have all the relationships for it, and then return series. So we return a list of either something or none, okay? And then we check if that list, I guess, is empty or not. So that's why we don't have a bunch of books that didn't have anything set on them. But we have some of them basically have a list of 3 books, but not the thing. Ah, this is tricky. So we should probably do, instead of that, say that, hey, give me the relationships of rows where series is not empty. And then yeah, and that's it. So we should do it that way. So the same thing would be here. Select value, row.series from where wrote, but wrote needs to be not series, and we don't need one of those. This might have been better. So let's just clear all the series set on books. Okay. And run this now. Same thing. Yeah. Very interesting that so we get the book. So it's fine because at this point we basically already got the books that at least have at least one relation that actually the series is set on it. So that's good. And then we set that series to, and we basically get all, for that book, we get all the rows of the series. But what are we limiting here? So this where statement, this where statement is regarding only this in here, which is the one thing where we already verified it. We should verify it in here instead. So could we do from... Okay, this is getting confusing. But kind of fun. So Mithridate says, technically the double exclamation mark checks to see if something is null, or a default value, like an empty string, 0, empty object, etc. Okay, that is very interesting to know. Too bad it's not in a documentation, isn't it? Because we saw some of those in operators. Do we have double exclamation mark here? No, we have only single exclamation mark. Because the other one just reverses the previous one. But it would be nice to have the double exclamation mark here in the documentation, because it's, like there's nothing that can replace it. We couldn't check for null in any other way, and checking for none, is like a really common thing to do, I believe. Interesting. Mithridates sounds like you're coding. Cool. Yeah, I must say that finding a way to check if something is null, because in SQL you will have, is not null. I guess you can do that, but because here we have null and the concept of a property or whatever field not being set in the first place, we should be able to check for is not none. that should be in a database, I believe, rather than finding workarounds somewhere else, because that would make the code so much more readable. Maybe there's a reason why it doesn't exist, but I don't know. It just feels like something that could improve things a lot, especially for beginners like me. You could use when something is not none and something is not null, etc. Yeah, but we just saw that the is not null kind of didn't work. Possibly where series is not none. If I'll try to do it again, now it works. So I wonder why it didn't work in the first place. Huh. This is interesting. Series is not none. Yeah, it works here. But it didn't work if we had route.series is not none. This wasn't working, right? Oh, this works here. Wait, what? What the hell's going on? So I guess in a subquery, route.series is not none. Oops. I need to comment those out because I'm doing a bunch of stuff right now. Okay, this is working. Why is it working now? Why didn't it work before? I don't understand. This is the first thing I tried. Okay, suddenly so it didn't work. Mithridate says, I think it was the where that did it. Okay. Possibly. I'll be on the lookout for when I found an issue like that. But for now, I'm gonna just undo it to the way I had because yeah, this worked. So in this case, I can have those to be series is not none. Okay, so this is good. This is good. CP says, see you later, everyone. I gotta go. See you around. Take care of yourself. Alright, so continuing. So we still have those nons placed in between, which is very confusing. Let me just run this thingy to clear everything out. And I'll actually comment everything else out because knowing me, I'll be running the whole query. So at this point, this plus this makes sure that we get only books that actually have for which the rote relationship has the series set, at least in one of those rote relationships. So now when we're setting it, we need to have an array without those nulls. So we basically, for the value of series, we're setting it to, so take the book, and on that book, we right now basically say that, hey, only that book. So because this is only one element, this whole where statement is pointless at this point. We will basically need to be able to specify that this. So can I just straight up say this? If that will work, I will be really happy. Oh. That worked. Okay. And that means we don't need this. Yeah. Okay, I didn't expect to just be able to slap it on here. That's awesome. Oh my gosh, that's gonna simplify so many things. Oh, hello, Taras. And I forgot about Twitch. Of course, I forgot about Twitch. I need to figure out the whole. I just need to add like sound notifications to when there's a message coming in, either on Twitch or YouTube, maybe with different sounds so I know where to look. How are you doing? It's interesting to see you on YouTube out of nowhere. Okay, I am really proud of the query now. Because on several reasons. We took the update for the book, okay? We were able to filter out those books through this query where we solve the problem of checking how to check for if the field even exists on the relationship itself. And then we're able to set something with a subquery where we refer to the object itself through this, which is, I'm very pleased to see that it works. And we take the array where we actually filter out not in where statement, but already in a relationship in here. Gosh, this is just... There's so many places where you could put little queries here and there, subqueries or where statement or some other things, that it's starting to be overwhelming. But at the same time, I feel like when I will learn it a little, a little bit more, this could be really powerful. It's just figuring out where are the places that you can actually test it. So right now, our books have the series The Expanse everywhere, right? But times 3. So this is where we could probably do it a little bit more in a more interesting way. Instead of saying series is this, we can do series array distinct, okay, and plop it here. So this suddenly should remove all the duplicates. Or not. Oh, because we have an array of arrays? Series is an array that takes this array. Why is that? Oh, I think I know why. So look at this. So our subquery where we try to assign the series to, we take the book, right? And we select all the wrote, what do you call them? All the wrote relationships. So it will be 3 in this case, or 4 or something. And for each one of them, return a series. In this case, we filtered out one of them, so it will be 3 of them. So really, this thing, we can imagine that this is as, all series, right? This is already a list that we return as a value. So that value will contain a list because we just return one list. I think there's something about flattening, right? There should be. Because we should be able to just extract the list out of the list, or alternatively take that select that we have here, okay, and just take the first element. Because we're guaranteed to have that element because we already did that. So this should extract the first element, which will be this array, and then we'll be able to remove duplicates. Oh, this is confusing. But yeah, now it's fixed. It's fixed. Okay, cool. So what if we have something like Color of Magic? This is really belonging to multiple series. But that would make... Let's say that one of the... Just for fun. Let's say that book B3, which is Abaddon's Gate. Let's specify on that relationship that it's series disk world, okay? Just for fun. I want to see if this will still find it and set it for that book. There we go. Now it's part of 2 series. Okay, all right. This is good. So in that case, I would like to find all the relations wrote and remove the series from them. Because it makes more sense that that book holds what series it belongs to rather than the other way around. Tara says, I'm a bit grumpy today. Okay, we'll go and listen to music. See you. See you too. Yeah, grumpy days are not fun days, that's for sure. Yeah, I came up with fever today and now feel a little bit better. So I guess I'll be able to work tomorrow, but somehow SurrealDB, now those little wins give me more energy to keep going on. All right. So, yeah. So let's do that. Let's do update. And we'll do wrote, where series is, set series to none. Okay? This should remove all the series from wrote. Bam. No more. Therefore, if we would run that, nothing should happen, right? Empty. And none of the relationships from, those fields from the book should be removed. I hope. Series. Yeah. Array. Bam. Bam. Cool. That's very much fun. So now we have that series. What if we would try to make... Because I'm still trying to figure out the relations. What if we would... Because, we have those bunch of those series. They are connected many times. What if we would be able to basically write a few queries that will go over the books, extract all the series from those books, create a new table that will hold those, specific series. In our case, it will be just 2 series, the Expanse and, what do you call it? Discworld. And then for all those connections, it will create relations, and then we're going to remove the series themselves from the books. This way we would have something yet different. Sure, let's do that. So I'm going to start a new query. I'm going to actually rename it to extracting series to separate table. Okay. So let's do that. We need to first get a list of all the possible series. So I would say that we have let, right? Let, and we'll just do series. Kind of difficult to make it plural. Series is, and we're gonna do select. We're gonna do from book. Okay. Series from book where series is not none. Okay. And what we're gonna do here, we're gonna make it into values. So this should be an array of values, I believe. But we're gonna do array distinct so that we have only unique ones. And can I run this? Will it return anything? Can I like return series? I guess we need to end those with. Okay, so we get a list with expands, a list with this, a list with that. All right, I see, because the series is already an array. So we got a bunch of arrays. So I guess here we definitely need to flatten them. There must be something in the thing. So let's see if we have something like array functions. Add all, append, combines all values from two arrays together. Okay, just from two? Yeah, it's just from two. Clamp, concatenate, difference, merge values from two arrays. Array and array, again, two arrays. If you want to remove duplicate values from the resulting array, you can use union. So distinct function calculates the unique values in an array, returning a single array. How is that different from union? Oh, union just combines the two into one. Okay, so it's like two things at the same time. But again, just two arrays. Sort, shuffle, reverse, push. Last join returns concatenate value of an array with a string in between. Nope. Group flattens and returns the unique items in an array. And then we have flattens multiple arrays into a single array. So flattens an array of arrays, returning a new array with a subarray elements concatenated. So if we had something like flatten and we have array of those elements, it should return. Oh, it just goes deep because it takes this one and flattens them out too. All right, I see. And how about group? Yeah, Gabriel says array flatten, exactly. Well, the array group function flattens and returns the unique items in an array. So the following example shows this function and its output. So we have array that starts here and ends here and has 1, 2, 3, 4. Then these in a subarray, another subarray. But it just groups. Yeah, this is what we want. Group. And on top of that, returns only the unique items. So this is like the group combines flatten with the distinct. So all this is fun. Let's try group. Run it. There we go. Look at that. Okay. So we have flatten and we have group. And group is extra powerful. Cool. And by the way, you can use return statement to return whatever you want. You can even return hello world. Okay. So if I'll run this, it just returns hello world. Or can return an array of hello and world and whatever you want. It should work here. Okay. I believe we can do return book color of magic. Will that work? That returns magic.id. It should return itself. But we should be able to do .name. Because remember, we can just use dot to access things. So it's as if you were running a join here or select query or something. Name. There we go. Huh. Dot series and the first one. Bam. Cool. Okay. So we have basically the list of all series. So what we would want to do here is create basically a element. So we would need to do create. We'll have series, and there will be some kind of name, right? And we want to basically set name is an ABC, right? Some other name. So how do we do that for those? And keep track of those. So one way to do that, because when we go to create statement, let's see if create statement shows an example of making more than one. So the create statement can be used to add a record to the database. Doesn't mention many. Creating multiple records, or even multiple record types can be created by separating record names by commas. Oh, create this, comma, that. Okay, not great either. Because I would like to... What if I'm gonna pass it a list or something? Can I do that? I want to just try it. Create, and we're just gonna do test 1, test 2, and test 3. But then they will all have the same name, so that kind of sucks too. Set name is there. I'm sure this won't work. Yeah. Okay. Mithridates suggested exactly the same thing. Yeah, from 1 to 3 or something. Yeah, we could just do this. Sure. But it doesn't accept this form. I guess we could do it this way. And this will work. Okay, so we can't use that value either. All right, so the create statement is definitely just for one thing. Pipe operator, not square brackets. Oh, pipe operator. Is it in operators? Do we have a single pipe operator? No. Oh. Interesting. Where is that in the documentation? And that just worked. What? Okay. Mithridate says I just added a PR for that too. That's awesome. Wow, so there's lots of hidden features. Interesting. I'm glad I can help in finding those little missing pieces. All right, so that allows us to create multiples, but they will all have exactly the same value, which is not great because I don't think we can just do that to have different names for each, right? Yeah, I don't think we can do that. So the create is basically give it a value and just deal with it. But I recall there's this other one. Insert, right? The insert statement can be used to insert or update data into the database using the same statement syntax as the traditional SQL insert statement. This statement cannot be used to create graph relations. Of course, yeah. So what we can do here is insert into, and we have a table, and we just give something, right? But yeah, so this is a single record. Insert into table, we specify the fields, and we give them the values. but then multiple records. We can just do first record, second record. But can we use lists for that? On duplicate key, update this and that. Okay, so we can even do detect duplicate key updates and stuff. Duplicate key update. When using the values clause, it is possible to update records which already exist by specifying a duplicate key update. Okay. This clause also allows incrementing and decrementing numeric values and all that stuff. Okay, we don't worry about that. Search statement is possible to copy records easily between tables. So we can insert into records San Francisco. And we just do this. Select everything from temperature, where city is San Francisco. It doesn't mean that we could just do... Furthermore, it is possible to perform bulk inserts in a single query. The what part of the syntax can be either a single object or an array object. Okay, so this will insert 2 persons. Okay, that starts to look like something we could do, or something of this sort. Because here we select the series, right? So in theory, we could do something like insert into series, okay? And then what we want to put in there. And I guess this would take all the temperatures from that specific city to put in there. So it'll be multiple elements of multiple tables, right? I think. So let's do insert into series, and we do select. And there we can just create an object, right? So select how do I do that? How do I create those objects? Because I'm just trying to find a way to avoid using a loop, because there's normal for loop and we can do stuff. But I'm just thinking, can we just take this and do it in a single query? I'm not sure how to actually extend that. So let's just do the loop for now. I give up. I won't waste your time. So the for statement. The for statement can be used to iterate over the values of an array and to perform certain actions with those values. Okay? So for item in something, and then we have a block. So basically for name in the array, create something something. We can use that name here and there and just set things. So this is exactly what we could do. The question is, can I even move it further? The following query for statement. Yeah, I've got an idea. So let's do for series name in series. I mean, we could just put that here, but I'll just keep it that way. And then we just do this and put stuff in between, right? So here we could basically do create. We do series. And we could probably do series name. Do we have something like string lowercase or something? Because we should be able to do... I mean, this already is a string. So let's see if we can find something lowercase. String, lowercase. There we go. That's it. So we should be able to convert it to lowercase. Do we do it that way? Or let series ID, and we'll just do that. It's gonna be a little bit more like, you know, normal programming, but at this point, hey, why not, right? Series ID. Look at that. It's the syntax highlighting is suggesting that's not it, but maybe it's gonna work. I hope it's gonna work. Do we have an example of it here? Create type thing, person name, content. I don't know. We'll see if that's gonna work. If not, we can just always nuke the whole table. So create this, and we can just do set name is series name, because that's all we care about. Sure. So what's gonna happen if I'm gonna run this? See? Expect this delimiter to be closed. I did close it. I guess we are missing this here. Let me just double check it again. So, Oh, I see. We need a semicolon at the end there too, or not. But the series here, it doesn't like the $sign. Will it work if I will do it in parentheses? Because syntax highlighting it seems to be happy now. No. So I've got another idea. Instead of creating this thing, we can just do create series, set name to be this, and we can also set ID to be Oh, method date says type thing, I think, is the only way to do it here. Okay. I think I know what you mean. So if we go to type functions, we can create something called type thing. There we go. The type thing function converts a value into a record pointer definition. So we can basically define the thing, which is table name and the ID name. So we can basically say that table is person and ID is Toby. So we could do, instead of doing it here, let's just do it here. Type thing, which will be I guess it needs to be a string, right? Series, and the other one will be series ID. Of course, without the quotes because it already is a string. Okay, and this should be the ID, and we set the name to be something. So let's see if this is gonna work or not. All right, the second query did something, but we didn't get anything returned. I guess because these are subqueries. Let's look at our Explorer. We have series, and we have both of those set. Discworld and the expanse. There we go. The only bad thing is that we have spaces in the middle. Oops. Maybe there's some fancy string function to remove all the spaces and stuff. John, lowercase, repeat, replace. Okay. That would be to replace some stuff. Slug. That could be something. convert string into a human URL friendly string. So that's one thing. It could replace this with all lowercases, with dashes if we have to, but I think dashes will also make it have those funny brackets or something. Starts with trim, uppercase, words, and then bunch of checks. If it's a UID, if it's a server. Oh, that's handy. It's a date or domain. I really like that there are like some version. Thanks for incrementing major or setting it or stuff. That's awesome. What's gonna happen if we're gonna change it? First of all, I'm just gonna grab those two and delete them, okay? What if we're gonna make it to use the slug thing again? And instead of lowercase, we're gonna do slug. And that should replace the stuff with dashes. So we're gonna run this. And see, so dashes still make the ID have those funny brackets. And that's the one thing I want to avoid because, you know, it doesn't matter if you have millions of stuff, but I would like to have things readable on a stream. So let's just do quickly delete from series. Okay. This doesn't seem to be happy. Remove. How did that work? Come on. Delete. Delete person. Delete all records from a table. Oh, it's just like that. Okay. Bam. And that means if we refresh here, we have nothing. Cool. Okay, this will be a handy thing to just have here, uncommented. Alrighty, so if we have the slug with dashes, we are for sure now we don't have any other characters, so we could just straight up do string, replace, and how did it work? String replace. Replaces an occurrence of a string with another string. So basically, the following example shows the function. This output. Really? You don't have names for parameters? Come on. So I guess we take the value, we look for a test and replace it with awesome. This is awesome. Yep. So we're gonna have our slug. We're gonna find the dashes and replace them with nothing. Sure, let's see that. Refresh. Oh, there we go. No fancy brackets. We just have normal names. Perfect. And I don't worry about conflicts here because I know in my data there's none. All right. So again, I'm gonna remove a bunch of the stuff. But now what I would like to do is not only create those series records, I would like the series to have relations like includes and points at the book that relates to the series, right? So the create, doesn't it return something? Because I think we could just do like, hey, give me the ID of the thing that you just created, and that will be awesome. So where is it? Create. Have the only. Using the only clause after create will return just a record object instead of the default, which returns an object inside of an array. Create only. Person Toby said this and that. So that should return the actual thing. But then on top of that, we have this whole thing return values. By default, create statement returns a record once the changes have been made. To change that what is returned, we can use the return clause, specifying either none, before, after div, or comma separated list of specific fields to return. So I guess we could do return ID, because that's the only thing that we want to do. So we could do create this, set the name, and return ID. Okay. And if we'll make it only, that means that we can do let I mean, why do I even bother? We already have the ID. So this is not the ID. The ID is actually this. This is the actual thing. So we could do this. Okay. Screw the only, screw the let, screw the return, return none. Okay, we don't return anything. We just create it. And at that point, we already have the ID, so we can basically do relate from the ID to includes, and then we basically get the books that we need to create a relation to, which will be select ID from book where so let's look at our book, because book has the series which has array. Look at that. Okay, so we can basically say select ID from book where series includes, and we'll use the series name which we had before, but what was, because I recall we had those operators here. What was it? In checks whether a value is contained within another value. Not really that. I mean, return 10 inside this. Okay, that will be fine. This is regarding text. Okay. And there was some other thing, contains or something. Check whether a value contains another value. Oh, this is the same thing. Wait, what? Where's in? Inside. Oh, there we go. Checks whether a value is contained within another value. Oh, this is exactly the same. So this is inside. Oh, the other one is if this contains that. Okay. So if series n, contains. So we're series name n series, because this will be the book.series. I think that could be it. And that should create all the relations that we need, because this will return ID from books. So we need to do value to return just the IDs, and this will be a list. Let's see what happens. Run. We have the series and includes from the expanse to book 8, from the expanse to book 1, from the squirrel to book 3, from the squirrel to Color of Magic. Look at that. We've got the thing. So now, yeah, with this, we created the series and all the relations between them. Okay. So the other thing that we could do is basically, you know what? We want to query them now. Select it from series, right? We want to select the series, give me all the series where the series has a relation includes. No, what am I doing? Let's say we want to see all the books in the Expanse series. So let's get the series where name is the Expanse, right? This should give us the series, single one. And instead of select everything, we're gonna select that the series points through includes, and we want the out to be returned, which is the actual thing. Wait, not out. This will be the book. If we're gonna run this, it's gonna look weird. Yeah, this includes book and bam. So the first thing would be to. What happens if I do limit 1? Oh, not here. Oops. Here. No change. List of objects. A list that has an object that has the include. Otherwise, we have list of an object that has include. Yeah, the same thing. Yeah, it's exactly the same thing. Okay, so that doesn't make any difference. Interesting. Only. Wait, it was from only. I think. Because it will take only one series. Yeah, now we have better. So we've got this object that has includes, but how can I extract it to just an array so that it looks, half decent or is named like books or something? Because if I'll do as books, what will it refer to? Oh, okay, that worked. The whole thing was renamed as books. Okay, I like that. Select value. Well, doesn't mean that it will just return that. There we go. We just have a list of books. And I believe there was one more thing that we could do. I think it was fetch or something. So with select, there's connect targets using the fetch statement. So one of the most powerful functions of SurrealDB are the record links and graph connections. Instead of pulling data from multiple tables and merging the data together, SurrealDB allows you to traverse related records efficiently without needing to use joins. To fetch and replace records with the remote record data, use the fetch clause to specify the fields and nested fields which should be fetched in place and returned in the final statement response output. So I think this will be the last thing that we're going to try out. So basically, what we can do is, select something like artist email or whatever from review and fetch the actual artist. So review has an artist, which normally is just an ID. So we would have a list of an ID. But we can fetch it to expand it. Yeah. So if we do fetch books, I don't think that's gonna work. And that's limit 1. Fail to parse query at line. It's moving. What the heck? Fail to parse query at line 12. Expected one of with, where, split, group, order, limit, or start. Fetch. I think it just doesn't like to be combined with 1. Therefore, we remove the only. I don't know what's going to happen with this. Oh, look at that. It expanded them. All right. Can I still do from only? No. Do I put limit 1 here? Oh, this doesn't mind parsing. There we go. So if a list of books, okay, that are in the expanse series. Perfect. So we went that route where we took the series and then found the books and did a bunch of stuff. But what if we're gonna do the other way around? Because we want to get books in the first place, right? So let's do select from book from that table, okay? So select those books that are included, that includes points at, from the series. We don't want it here. We just want it to be where the book is included in a series where the series name is the expanse. And I think this is gonna be much nicer. Oh. Nope. It should work. Why doesn't it work now? So for each book we check, we get all that includes. All because it's a list, right? So it all that includes that are series. Can I just do this where name is the expanse or something? Oh, that's how we do it. Okay. I guess we just did it. So for each book, give me everything, but only for those books that includes relationship points to. So books that are included in the series. Okay? But only those series for which name is the expanse. But the question is, no, it's good, because name, the expanse will be only that books won't be called name, won't be called the expanse. So there we go. Or what was this? The other one, Disc World, and this should be silly because there will be one of the expanse books here. Okay, this is way simpler than this. So depending from which direction you're coming, it would make sense. All right. And what if I'll do select me only the books? Come on. From book where, let's pretend that there are no series, right? Inside the books themselves defined. I mean, we can just do, what was it? Update book, and we do set series to none. This way we're going to remove all the series entries from the books, so that we're left only with the actual relations. Okay, there we go. These are the ones in Discworld. These are the ones in the expanse. Cool. So what if I want to include only books, show only books that are included in 2 series? So I will do count, I believe, for books that are included, right? In something. Something has 2 relationships coming to it. Is that possible? Wait, is larger than 1. There we go. Abundance gate, because this is in 2 of the things. So I could probably add something like all those includes series as series. I will do fetch series. And I think this would add to this result the list of the series. Oops, I just run everything for some reason. I will never learn. There we go. ID, name of the book, and all the series in it. And expand it so that we have this. Perfect. But I don't think we should have to expand. We could probably do series dot name and not need to fetch them. Is that possible? Yeah, there we go. Wow, this is simple to shape data. Once you get the hang of it, I think it's really easy to actually figure out how to shape the return data. So I don't know, it kind of reminds me of GraphQL, I guess, in a way that you can kind of modify it. Yeah, this is really awesome. Okay, so if that's the case, you know, our designer now shows that we have series. Look at that, we don't have those links here. I guess we would need to go to the series and specify that the fields are this and that. So I guess we could do define field in on table or on, what do you call it, includes type record of, it's coming from series. Okay, we could do this, and we could do out to be book. Method date says define table, sum graph table, type relation, and we'll do it. Okay, yeah, that's the next step I wanted to actually do, because I wanted to take a peek at that one thing. So let me just define those 2. This should actually limit what we can do, and it kind of triggers the thing where it figures out, okay, if we have actually explicitly defined in and out, you know, the editor here will show that this is actually a record table, or edge table, as they call it. But on top of that, we can do one extra thing. So when we go to define, and we define table, we have one extra thing here, which is table, come on, I guess we need to scroll ourselves. Table with specialized type clause. So with type any, both relations and normal data can be stored on a table. So when we take a peek at those, right here, and the designer, and we click on includes, it shows table type any. Okay? So that means it can hold normal and relation data. We kind of forced it to be always relation, just because we already defined the in and out fields, which is like the only requirement to make it a relation. But still, due to SurrealDB so due to SurrealDB's schema-less nature, this is the default option if no type clause is specified. So something like define table person and type any. It's exactly the same as this. With type normal, you can specify a table to only store normal records and not relations. So I guess this could be still defined as normal, but then if we would try to run relate on it, it would freak out. Let's try that. Let's make a new query where we define table hates and we'll make it normal. Okay. So let's run this. Okay. In our designer, we have hates. So what if we're going to try to relate author Terry Pratchett hates author, I don't know, who would that be? Frank Herbert. I don't think he would hate that guy, but let's try if this will let us to create that or not. See? Found record, this, which is not a relation, but expected a normal. So that's it. So what if we're gonna make it any? Okay. Or yeah, let's make it any for now. And that will allow us to just run it, right? There'll be no problem. Yep, we created a relation. But what if I'm gonna define any and we're gonna do the thing that we did here, where we define it to be author to author, okay? And this will be this. So we define that. That means there should be no problem for, you know, let's just swap them. So they should hate each other the other way around. Okay, no problem. So if we go to our designer, I don't know, author now hates each other, right? But in our explorer, designer hates still Annie. So that works. But doesn't mean that we can just create a new, just normal thing. Create hates set in as this, and then we're gonna have out as the same, so it'll be he hates himself, and that's it. Can I do that? Because this is not a relation. Bam, it's fine. What if I'm gonna switch it to relation? With type relation, you can specify a table to only store relation type content and restrict what kind of relations can be stored. Oh, okay, look at that. So we can define table likes type relation, or you can define a relation table and constrain the post type of relation which can be stored. Define table likes type relation from user to post. Oh, so this is different than define fields. Okay. So from user to post, or schemaful type relation in tag out sticky. Okay, so I guess from is equivalent to in and to is to out. Okay, and permissions were blah, blah, blah. Okay. I wonder how this differs from setting the fields. So let's just make it as relation for now. So we're gonna make sure that this is type relation. Okay, relation, yeah. And let's just get the Terry Pratchett and try to create a normal record, like create, that would suggest a relation. Can I do that? No, now I can't because it's relation. So only through relate it will be possible to actually create a new record. Okay, that makes me very happy. So let's just make one additional one because I want to inspect something. I mean, we can do info for table heights. We can probably run this, right? So let's see. We have fields like this and nothing else. Okay. I don't even know how to run for DB. Can I do this to get... Okay, so we have table heights and define table heights, this schema-less permission none. Okay. So what if we're gonna do define table loves relation from author to author? Will this show up here or will it show up as fields? So let's run this. We can check info for DB. For loves. Okay, relation in author, out author. So these were translated. Cool. So that means that if we're gonna go info for table loves. Okay, look at that. So it's suddenly it defined those two fields for us here. Okay. Find field in on loves, type record author, and this one is record author as well. Okay, I see. So this is pretty good. What if I'm gonna update it from author to book? Will that change some stuff around? Oh, it updated the definition here. Can I do to book or author? So it can point from one or the other. Accepted. And yeah, okay. This is pretty good, pretty great. Cool. All right, so it's nice that we can just define it one-liner. That saves so much time and effort. Huh. And I guess you could still use, define field, this or that. What would happen if I would do now? Define field and like change the thing here manually. Like change the field out on loves to be, instead of book or author, it will be just book. Or just author. How about that? Can I do this? Run. So if I'll go here, author and author, so that got changed. But what about the DB? Did that get updated? Yeah, that got updated too. Okay, so they kind of refer to each other. Interesting. Huh. So I guess it's still recommended to just do this from to or in out. And then if you need to add additional things, just do the define field. And they will both stay in sync, which is really nice. Alrighty. Well, I think we learned a lot. We actually started to understand the relations. We started to understand how to query them and do a little bit more complex things, especially... yeah, I mean, this is great. There was one that was very interesting. Yeah, this one, for example, with updates and stuff. Yeah, so I'm really enjoying it. I think we'll be finishing for now because it's late. I'm getting tired. I need a good night rest. So now that we defined this, the thing that I'm kind of wondering is, what are the trade-offs between using just those relations versus simply using record links? I guess with record links, you can just do dot something if you just need a direct access or expect that something just is defined. Or with relations, it sounds like it'll be easier when you have multiple jumping around. So the thing here is that we have this demo data in SurrealDB defined. Where you have something like Surreal Deal Store, okay? This is a bunch of data that you can easily import. I think it's like, 10,000 records of this, 10,000 records of that. So you can start playing with queries. But it shows this diagram here. Can I open an image, new tab? Wow, this is a little bit large. So let's look at this here. So the way this is represented here is that we have those, I don't know what you call those colors. This darker color, like person, payment details, address history, or product and seller, those are records, okay? And those dotted lines are basically record fields, okay? That product has a record that points to a seller, as far as I understand. While those not dotted arrows and those, purple or the violet color things like wishlist, cart, order, review, and product SKU, these are actual relations. Are they though? I'm starting to get confused. SurrealDB Store is our new improved demo dataset based on our SurrealDB store. The data set is made up of 12 tables using both graph relations and record links. In the diagram below, the nodes in pink are the standard tables. Yeah. The ones in purple represent the edge tables. Okay, so I guess these are purple. Yeah, like wishlist, cart, order, review. I believe I have this thing downloaded somewhere, so we can quickly check that out. Let me just find it if I have it here. Sure. So let me redo this. Okay, reset, and you can do, I believe, an Explorer. You can click import data. So I'm going to do that off screen quickly. And I'm gonna get the SurrealDB store. Yeah. It's 40 megabytes. Yes. Loading. Method says there's also a button just to the right of the reset sandbox that automatically loads SurrealDB. Yes, there is, but it has like the mini version of it. For some reason, I don't know why, I just wanted to load the whole one, and it takes a lot of time right now. Okay, there we go. So we can look that in the Explorer, we have a bunch of tables like address history, okay? And there's 10,000 rows, payment details, 10,000 rows. And then we have things like cart, order, product SKU, review, wishlist. All those, these are edge tables, okay? So these are just relations in, out. So when we look at the diagram, you can see that, okay, so those are actual edge tables. And those edge tables have, like person's cart that basically we have person has a relationship cart to product. Okay? So, I would call it in cart, but that kind of makes sense. So instead of having it's just interesting. Let's look at the cart. Yeah, here we have the cart, and we can say that this is ID from person to product, and we have additional things like color, currency, price, product name, quantity, size, and time, like created ad and updated ad. Okay? All this is defined on that edge. So beyond just ID in and out, we have a bunch of extra data defined here. Incoming and outgoing relations, all that stuff. So from that perspective, it's kind of like a shift in thinking. Like, this is interesting, because suddenly I can say, you know what, I could probably do something like, because this is from person to product, so I could easily run a query, like select, and I want to do from person, and maybe a specific person, right? So let's go to Explorer, let's get person, or I'm just gonna get it from the cart so that I know that this is there. So ID, let's get that specific person, okay? So I could say from that specific person, get me all the cart items, okay? Run it. And we see that there are 2 cart items, okay? But I could do actually dot out, or maybe just product. And this would just give me a list of products that it points at. So let's do it as product and cart. And we'll do fetch product and cart. And we can see that we have first one and second. I mean, from here, we have the first product and the second product. So this is how, this simple query gives me everything that they have in the cart. But, this is relatively simple when you think of SQL. But suddenly that also opens up the possibility, you know what, I want to see who has this thing in the cart, right? So select, and we'll just do from product, and I want a specific product in my case. I want to see the product, whatever this product is, right? Here. I want this specific product, and select me everything, all the cart items and person that are pointing at this particular product. Okay, and as customer, right? Fetch customer. So I can run this query, and these are all the customers that are pointing at it. There's a lot. So maybe instead of doing that, I want to just do count. Customers count. Okay, and no fetch needed. We just want to see how many people target a specific product. Just this one, 162. Okay, so maybe we just want to go to product and have the what is the final product? Do we have something like a name? Yeah, we have name. So we can basically show me all the names and carts, or like carts, and run this query. And for every product, we'll see how many people have it in a cart. Okay, simple things like that. Or maybe we want to see the average number of let's do average number of items in a cart per customer. Okay, so in this case, how could we do that? So we for sure want to start from person, right? And we want to so what the hell am I thinking? Sorry about the bright light. We should have something where we want a person, cart item, right? And we want to count them. how many cart items per person. But that would just return per person, right? How many items? I presume I could take this whole thing to just return one number. How do I do that? Count function. These functions can be used when counting field values and expressions. So the count function counts the number of times that a function is called. This is useful for returning the total number of rows in a select statement with a group by clause. So do we get any interesting examples? Return count of this, count of true, count of this larger than that. Just a bunch of weird edge cases. What the heck? I want something decent. So select count from this and group all. So I guess we should read up on group all a little bit. Yeah, because this is, per country and whatnot, that's all fine. But in the select statement, there was this whole thing group. So we can quickly learn about that. The group by and group all clause. SurrealDB supports data aggregation and grouping, with support for multiple fields, nested fields, and aggregate functions. In SurrealDB, every field which appears in the field projections of the select statement and which is not aggregate function must also be present in the group by clause. Every field which appears in the field projections of the select statement. So let's just look. Select country from user and group by country. Also, basically, all those fields that are specified here, they all need to be in here. Okay. So group records by a single field. Group results by a nested field. Okay. By multiple fields, sure. Group results with aggregate functions. So select count as total and math mean age as average age, gender, and country. Oh, as average age, and then gender and country. And from person, group by gender and country. So that means this and that doesn't matter. We just return those. Okay. And get the total number of records in the table, which will be person, group all, and count them. Okay. Select unique values from a nested array across the entire table. So let's play around with it a little bit. So count stuff in the cart. As what would we call it? As count. Items in cart. Okay? So this will be our starting point. What's going to happen if I'll do group by items in cart? It's gonna freak out or something? Nope, I have no idea what just happened. Can I do count as total? Come on, this, and we'll just do group all. I'll be honest, I have no idea what I'm doing. So, items in cart. Looks like everything was added suddenly, and total is 10,000. So, okay, I'm not sure what I'm doing now. So yeah, the total number works because we know that we have 10,000 persons. And count cart. I guess most customers have empty carts, I'd say. Right now I have 3950. Can I just count customers where cart of the word account of items in the cart is larger than 0? Okay, so it's that many. All right. So this doesn't really work because items in the cart, they're just all grouped and just added up as one per thing. How do we do that? Mean? There was something here, math mean. And we just give it the age, so that should calculate automatically how many items there are. So count of this as items in cart. Should be the average. Whew! Now we got 0. Because this wouldn't make sense, something like that, right? Division with 0 and 0. Do we need to like do a subquery or something? I think so. Because one thing is to get an age, but the other thing is to extract something else. So if I would return from select, and that will be the items and cart. Okay. So it'll be as items in cart. So it'll be count cart as items in cart from person. Okay, so this should leave us with the thingy. So we should be able to do mean of this as average items per cart. Okay. And this should make more sense. Ha, still nothing. What does this return? 1, 1, 2, 0. Is it really average 0? So, I mean, it returns per item, items in cart, right? So that should not be a problem to extract items in cart per those. So just in case, let's just see what happens if we're gonna run this. Just select items and cart. Like this. Okay, we got a list of all those elements, average items per cart. So that is fine. Group all. That would be suddenly confusing. Well, why doesn't the average work suddenly? Because it should work, right? Here we have group by as well, right? Oh, here we have just group by, not the total. But we could just get the total number, yeah. Okay, I'm being confused right now. Ay, ay, ay. Yeah, because suddenly shows 0. I wonder if I would need to make those to not be something like just normal number. It would need to be a float or something, but that kind of doesn't make sense. Let's see if we have example of math mean. Math functions. Mean. Array, number, blah. So we have this example and I will return that. That's it. Oh, okay. So this tries to take it wants a list of values. I'm not sure how that works here then, because it should be aggregated, right? Because if I would just return this, even though we have group all, no. Okay, I don't know how that aggregation works. I'll need to read up on that because that's the one thing I don't remember how it works in SQL as well. I wish there was a bit more of explainer on that subject. Yeah, because we have select, group all, and supports data aggregation and grouping, and that's all. Support for multiple fields, nested fields, and aggregated functions. In SurrealDB, every field which appears in the field projections of the select statement and which is not an aggregate function must also be present in the group by clause. Okay, so I understand that we can group them by country, group records by a single field. And doesn't mean that that field suddenly... Sorry. I am not sure exactly what that means. How does it aggregate them? Let's say I'll get persons. I want to aggregate them by as the first name will be John. We'll get something like that. Select first name from person group by first name. Okay. What will that return? I mean, I just got the names and I guess duplicates removed. Yeah, but that's... Oh, I see. And then I could do something like count the... Oh, count them as occurrences. I will see, oh, how many times that specific name. Okay, so this number there is somewhere in the back. Randomly. I see. And group all. How will that differ? Oh, that just combines them all into a single thing. Okay. That starts to make sense. So in my case, I'm trying to get how many items per cart. So I want them all. And for all of them, I want to extract the number of the cart. So in theory, this gives me all the persons and how many items there are in a cart, right? So then I can just do math mean on items in cart and group them all because that's what I want to count. But it doesn't work. Do I need to do something like, what was the data type? Numbers. Decimal numbers. I think it was somewhere here. Float. Do I just do float like this? Will that work suddenly? Oh, we got half. I guess there's half an item per person. Exactly half an item. It's very weird that it's exactly one per item. So if I'm gonna grab relate, and I'm gonna try to relate each person to a specific product, something like relate select what can I just do the whole table? Oh, like select ID from person. Okay, so we just selected all the people. We want to relate them to via cart to, oh no, that would be very rules for the cart, right? To a specific product. And in this case, I can just grab a product. I don't know, this one. And just try to relate it. Will that work? Or will we get like info like, oh, this unknown for the field color. There we go. Set color. That's English spelling, huh? Is whatever. Hard to tell. Okay. It's gotta be a color. Currency. Currency is I don't know, what's the PLN? Okay. And that would be probably 30 other things not working. What else needs to be set? Price. Price is -1. Okay. Product name is product.name. Okay. Please finish already. Let me just cut it out of here and just plop a new query so I don't have to have it selected every time I run it. Size. Record expected string. Small. Oh, of course, time. So how was the time in there? So already got to time. Cart. Time needs to be created at and updated at. I guess I need to set it manually. It kind of sucks. Time dot created at time now. Time dot updated at is time now. Okay. Hopefully this is the end of it. Yes, we created a lot of records. I believe 10,000 relations. So if we get back here, we should be able to get a number 1.5 now. Yes. Okay, this works. It actually works. All right. If that works, I'm satisfied. And yeah. Okay. Learned even more than I expected. So if we have that, now I'll be able to contemplate how to actually implement this whole commenting system and whatnot. Because I must say, I like those relations. But maybe next stream, next Wednesday, for some of you, will be next Thursday in morning. We'll take a look at the idea of defining a schema where we have users, we have posts and a blog post, and maybe series and topics. And the idea of adding like knows relationship for some posts so that they learn something, likes, like user can like a post or a comment, and actually leaving comments that can also point to other comments as parents or who they belong to, which post they belong to. We'll be able to talk a little bit more about how to design a little bit better, and that should work hopefully. So yeah, that'll be it. And I thank you today for watching. Thank you so much for Mithridates for helping out, Gabriel for helping out. And Mithridates says, awesome stream. Thank you. Yep, it's Thursday morning over here. Yeah, I found that most of my viewers are definitely not from the US because everyone wants to sleep around midnight. So yep, thank you again for watching. Thank you for helping out. And if you liked the video, consider liking it, consider subscribing on YouTube. If you're watching on Twitch, consider following there. And I'll see you possibly on Friday, talking about NIM, reading more of the manual. So thank you again, and take care, guys.